Everyone, today I am going to discuss about one of the important source coding technique, that is Huffman coding. So in the previous lecture I have already explained about Shannon-Fano coding. It is one of the fundamental technique under source coding method. Now here I am going to explain about second important source coding technique, that is Huffman coding. Just let us see. So all of you kindly watch the previous lecture about the introduction to source coding technique and Shannon-Fano coding. In that I have clearly explained about what is source coding technique and why it is used in daily life digital communication, and how to implement Shannon-Fano coding technique for a given message or for a given set of symbols. So just once again we'll see what is source coding technique and then how to implement another one under the source coding technique, that is Huffman coding. So here source coding technique is a coding technique which assigns a group of bits for each symbol that is coming from any discrete source like computer, mobile phones, or any digital device, etc. For example, if you consider any mobile phone and if you want to send a message through WhatsApp or any other sources, so if you type a message that is hi, how are you, that indicates that from this discrete source you are sending a discrete symbols one after the other in a sequence order as like your message. For example, if you type H and then you type I and then you type H and then you type O and then you type W and then space and so on like that. So whenever each symbol is coming out from this source, so that symbol will be taken by the source encoder inside the device. So that source encoder will assign some group of bits, it may be 3 bits or 2 bits or 4 bits, some group of bits to each and every symbol that is coming from this discrete source. So after that, if you combine all these codes for all the symbols, then a set of sequence of bits for corresponding to this message will be converted finally. So finally, whatever may be the message or information that you are going to send, that is finally converted into digital sequence in the form of ones and zeros. Okay. As you all know that for any digital communication, all the information, it may be in text or image or video, that finally converted into digital data in the form of ones and zeros. Only these digital data will be transmitted in the channel as electrical pulses. Okay. So this is the main purpose of source coding. Simply speaking, it converts some information or it converts a message containing a group of symbols into a sequence of bits. That's it. So in that we have two types, fixed length coding, variable length coding. These are the main categories. So fixed length coding means if the number of bits assigned to each and every symbol are same. For example, for this message, for all the letters, if you are assigning only 3 bits for each symbol, then that is a fixed length coding. That means the length of the code is fixed. If the length of the code is varying, that means for H you are assigning with 2 bits only, but for Y you are assigning with 4 bits, then that means assigning codes to each and every symbol is varying, then that is known as variable length coding. So practically variable length coding techniques are used in practical digital communication in all the mobile or internet communications. So in variable length coding we have two types, Shannon-Fano coding and Huffman coding. These are the two methods, fundamental methods that are used for variable length coding. Now we are going to discuss about Huffman coding. So before understanding the Huffman coding, let us focus on what is a symbol and the corresponding probabilities. For example, if you consider discrete memoryless source like this, if you consider any source, from that source some set of symbols are generating like x1, x2, x3. This is our assumption. Okay. So sometimes, for example, if you observe this message, if you observe each and every symbol, some symbols are repeating and some symbols are not. For example, if you observe H is repeating 2 times. But if you observe letter Y or symbol Y, it is repeating only 1 time. And also, if you observe other symbols like O, so O is also repeating 2 times. That means some symbols may occur more number of times and some symbol may occur only 1 time. So depending on the occurrence of symbols in this spaces of message, we can able to calculate the probability of each and every symbol. Okay, suppose H is repeating, so that means the probability of H is high, but Y is not repeating, so the probability of Y is less. Like that, for each and every symbol we have a probabilities. For example, the symbol is assumed to be x1 instead of these messages or letters. You can generally assume like x1, x2, x3 and so on. If you combine these x1, x2, x3, it will form some message like this. Okay, so this message contain letters, symbols, characters, numbers, special characters, etc. Okay, so anything can be obtained from this source. So as you know that symbols can be letters, numbers, special characters, etc. Let us assume those symbols as x1, x2, x3 and so on, and the probabilities of those symbols as p of x1, p of x2, p of x3 and so on. Okay, so this is the data we require in order to implement any source coding technique. That means what is the data we require? How many number of symbols are there and what are the probabilities? If you know these two informations, how many number of symbols and what are the probabilities of each symbol, then it is very easy to apply any coding technique. Only this information is required. Okay, so as I already said that source coding, what is the meaning of source coding means every symbol is going to be converted into some group of bits, either it may be 3 bits, 4 bits or etc. Since we are saying that Huffman coding is a variable length coding, that means some symbols are assigned with 3 bits here and some symbols are assigned with 4 bits. That means the number of bits assigned to each and every symbol is varying. So that is known as variable length coding. Okay. Now that is what about introduction to source coding, and now we are going to finally start the implementation of Huffman coding with a proper example. In the previous lecture, we already discussed about Shannon-Fano coding. So to implement any coding technique, we need to follow some algorithmic steps. Step by step, if we can implement properly, so finally we will get the code. Similarly, we have a already it is implemented. So please watch the previous lecture about Shannon-Fano coding so that it will be very easy to understand. Next, we'll start the Huffman coding. So again in Huffman coding we have algorithmic steps. There are 4 fundamental steps we need to follow. Okay, so no need to read these steps without any knowledge or without any practical example. So I will make these steps, I will directly implement these steps parallelly while explaining the example. Okay, now let us see the first step. That means list out the source symbols in the decreasing order of their probabilities. So what is the meaning of this? Just by reading this statement you cannot understand what is the meaning of this. That's why I just seen example. Here take an example as a discrete memoryless source has 5 symbols. I already said that the information required in order to implement any coding technique is the number of symbols and their probability. So it is clearly given as it has 5 symbols with probabilities are 0.4, 0.2, 0.2, 0.1 and 0.1. Clear. So we need to apply Huffman coding and find the code words for all the symbols. That means what is the meaning of this? Like this. For all the symbols, finally we need to find the codes. Okay. Suppose what is the code for x2 symbol, that is 10. What is the code for x3? 110. So this is already explained under Shannon-Fano coding. So similar to this, we need to apply for Huffman coding. Okay. Now for this example, let us try to implement this step 1. Here we know about source symbols. How many source symbols are there here in this example? 5 symbols are there. Let us assume those 5 symbols as x1, x2, x3, x4 and x5, and corresponding probabilities as p of x1, p of x2 and so on. So first step is list out the source symbols in the decreasing order of their probabilities. What is the meaning? List out the source symbols in the decreasing order of their probabilities. That means all the symbols must be arranged such that the highest probability symbol must be written first and lowest probable symbol must be kept at the bottom. Like that, the probabilities are arranged in a decreasing order like this. This is the first step. Like that, we need to form a table containing, this is the list of source symbols arranged according to the probabilities in the decreasing order. So stage by stage, we need to apply and repeat the Huffman coding procedure, and finally at the end of last stage, we will get the code for each symbol. Now let us see. This is the first step. So first step is very important in order to perfectly get the codes. So first step is arranging the source symbols in the decreasing order of their probabilities. That is highest probable symbol. Let us assume that as x1, or else you can assume anyway. So since these are in the example, these are given in an order. So 0.4 is assumed as x1, that is highest. So that is first placed, and x5 is having the probability 0.1, which is lowest. So it can be arranged at the bottom. If there are two symbols having same probability, you can arrange as per the order given in the example. Okay. Now coming to the second step. What is second step means? Assign 0 and 1 to the two symbols of lowest probabilities. What is the meaning? The two symbols of lowest probabilities. Suppose if you observe this order, what are the two symbols with lowest probabilities? Automatically the bottom two symbols, because the probabilities are arranged in a decreasing order. So last two symbols are having least probabilities. So for these two symbols, we need to assign 0 and 1. So we need to assign 0 and 1 to the two symbols of lowest probability. So let us assign 0 to upper one and 1 to the lower one of these two symbols with lowest probability. For example, we identified that these two symbols are the having lowest probability because they are at the bottom. So assign 0 and 1 to the least two probabilities. So I am assigning 0 to this one upper and 1 to the bottom one. So that is what the second step. And what is the third step? Third step is combine the probabilities of the two symbols. That means we need to add these probabilities. So how to add this 0.1 plus 0.2, that is sum is 0.2. So combine the probabilities of the two symbols with least probabilities, and then what to do? Then continue step 1 and 2 until it has only two probabilities are remain. So after adding the probability, we need to continue from step 1 and 2. So here we add these probabilities. So sum will be 0.2. Then we need to continue step 1. What is step 1? List out the source symbols in the decreasing order of their probability. That means if we add these two, the sum will be 0.2. So that means these two symbols will become into only one symbol having only one probability. So then in the next stage, the total number of probabilities only 4 instead of 5, because we are going to add these two into a single one. Then the first step is again we need to arrange these probabilities in the decreasing order of their probable values. So after adding also, if this addition is greater than 0.5 or 0.4, suppose if the sum will be 0.5, then we need to place this value above this 0.4. Or if the sum will be 0.3, then that 0.3 will be arranged above this 0.2. Since here 0.1 and 0.1 both are added, then the sum will be 0.2 only. So that is same as the above. So that's why it is just keep below the previous value. Okay, that is the again arrangement of decreasing order of their probabilities. Okay. So arrange like that, and we need to keep on repeating this procedure. So this is in the next stage. Again identify the probabilities with least values, or identify the two symbols with least probabilities. So out of these four, these two are the symbols with least probabilities. So assign 0 and 1 to these two symbols as we did here, and add these two probabilities, that is 0.4. Since 0.4, if you add these two, the sum will be 0.4. Means total how many probabilities are there? 0.4, 0.2 and 0.4. That means only 4 probabilities are there. Again we need to arrange these probabilities in the decreasing order. Decreasing order means highest value first,
next highest will be second, next highest will be not 0.4, not 0.2, that is 0.4 only, because we already added these two. The sum will be 0.4, and then only this 0.2 value will come here. Okay, and next again repeat the procedure. Again identify the two symbols with the least probabilities. That means these two symbols. Assign 0 and 1 to these two symbols. Okay, so the sum will be 0.6. So total how many probabilities we are getting? 0.4 is 1 and 0.6. So two probabilities are there. Again we need to arrange these probabilities in the decreasing order. Decreasing order means highest probability must be written on the top. So what is the highest probability? 0.4 and 0.2. The sum will be 0.6. So this is the highest. And next highest will be only 0.4. So that's why 0.4 will come here and 0.6 will come here. Okay. Similarly, we need to indicate all the directions with the arrows. So where the sum is going in this order. So where the sum is going, and where the next probable values in the next coming order. In the next coming stage, the order will be automatically changed according to this sum. So we need to indicate with the arrows. So where this probability will go in the next order. So where this sum probability will go in the next order. Okay. Suppose if you observe this 0.4 and 0.2, 0.6. So 0.6 is the highest. So that is placed at the top. So 0.4 will be lower than 0.6. So 0.4 will be come below this 0.6. So that's why we need to indicate with the arrow. So 0.4 will come here. 0.6 will come here. Next, repeat the procedure. Assign 0 and 1 to the least two probabilities. That means only we have two probabilities. So finally we can assign 0 and 1. Next, there is no further continuation of this procedure because only two symbols are there. What is the last step here we observe? We need to repeat these steps until it has only two probabilities are remained. So finally we have only two probabilities are remained. So the procedure will be stopped here, and then the most important thing is how to identify the code for each symbol, how to write the code. So what is the code for x2, what is the code for x3, how to write. So that is very important. So that is the last step. The code for each symbol is found by tracing backward sequence of zeros and ones assigned to them. Okay, that means for each symbol we need to write the code in a backward sequence. Let us see how we can write this. Okay, now I am going to observe the code for x2 first. Let us see what is the code for x2. First, it is very easy to understand how the codes are assigned for x2 in a forward order, and then we can replace with the reverse order. For example, let us see x2. What is the probability? 0.2. So no code is assigned here. So move to next stage. 0.2. Again no code is assigned. Then in the next stage, this 0.2 value will be moved to here. Here the code is assigned. That is, what is the code? 1. Next, this 0.2 will be added here, and totally the sum will be moved to here. That means this is also moved to here. So follow the arrows. Just to follow the arrows. How this x2 value will be changed and moved. So this is moved to here. So 1 is assigned, and again this is moved to here. So 0 is assigned. So what is the forward code? 1, 0. So actually we need to write 1, 0 generally, but in Huffman code we need to write in a backward order. So first identify forward code, that is 1, 0, so that you need to write in a reverse order as 0, 1. Okay, this is one procedure. Otherwise you can directly trace the code from backward sequence. That means we need to identify the path for x2, so where it goes. So starting from the last stage, you can write all the binary values assigned to them. So here 0 is assigned, and then 1 is assigned, and then no code is assigned. So 0 and 1. So tracing backward and identifying arrows is somewhat difficult, but it is very easy to identify the forward code first. Just write them in a reverse order. Okay. So like that, try to identify all the codes here. For x1, what is the code for xn? Here no code is assigned, no code is assigned, no code is assigned, and it is moved to here, so 1 is assigned. So 1 in reverse order also only 1. Next x2, no code is assigned, no code is assigned, here 1 is assigned, and then 0. So 1 0 reverse order 0 1. Next for x3, follow the arrows. So point to no code is assigned, here 0 is assigned. So 0 and it is moved to here, 0, again it is moved to here, 0. So 0 0 0. In reverse order also 0 0 0. Next for x4, 0 is assigned, next it is moved to here, 1 is assigned, and again it is moved to here, 0 is assigned, and again it is moved to here, 0 is assigned. So what is the code, general code? 0 1 0 0. So in a reverse order 0 0 1 0. Okay, next for x5, 1 1 0 0. So 1 1 0 0. Reverse order means 0 0 1. So this is the code for each symbol. Finally, we got the code for each symbol. For x1 we assigned 1, for x4 we assigned the code as 0010. That means you can clearly observe that for some symbols we are assigning with less number of bits, and for some symbols we are assigning with more number of bits. That indicates that it is a variable length coding. The advantage of variable length coding means we can able to reduce the final total number of bits for each message. That means the number of bits assigned for encoding can be reduced by using variable length coding, so that it is very useful for compression technique. In the compression technique, every data is going to be, the size of data, whether it may be text or image, the size of the data is going to be reduced. Size is reduced means, for example, from 100 KB to 10 KB, the size is reduced means the number of bits, KB, kilobytes, kilobits, the number of bits are going to be reduced. So if you use variable length coding, some of the symbols can be assigned with only less number of bits. So that is very very useful in compression techniques. Okay, so this is an example of implementation of Huffman coding with a proper basic example. Like that we can do for many. For example, this is another example. A discrete memory source has 6 symbols with probabilities are given. Apply Huffman coding and find the code words. And also sometimes it is asked to calculate the coding efficiency. Coding efficiency means we have a formula for calculating the coding efficiency, that is to identify the efficiency of a code. But just by applying the formula you can easily calculate. Now let us see this. How many symbols are there? 6 symbols, 6 probabilities. Just follow the procedure. All the 6 probabilities must be arranged in the decreasing order of their probabilities first. That means highest probability value first, next highest, and then least. So follow the procedure. What is the procedure? Assign 0 and 1 to the least 2 probabilities. Okay, least 2 probabilities, and then add these 2 symbols so that the sum will be arranged again in the decreasing order of their probabilities in the next stage. So next stage will be, here the sum will be 0.13. So that 0.13 is more than 0.12. So that's why it is above 0.12 and the 0.12 will be moved below. Like that we need to rearrange this decreasing order of their probabilities. Again the procedure will repeat. So again assign 0 and 1 to the least 2 probabilities. Add these 2. Sum will be moved to here according to the decreasing order of their probabilities, and so on it will be repeated. So according to the previous notation, the code for each symbol will be written based on the code that is written in the backward sequence. Okay. For example, in this case, let us try to write the code for x5. Code for x5. So let us see x5. 0 is assigned 0, then it is moved to here 0, and again it is moved to here 0. Here again it is moved to here, so 1. So totally 0 0 0 1, 3 zeros and then 1. So in a reverse order 3 zeros and 1. So reverse order 1 3 zeros. So like that the code for each symbol can be easily obtained from this Huffman code procedure. And finally, if you want to calculate what is the code word length, that is L of xi, you can represent with the letter L of xi. That means L of x1, L of x2 and so on. length of the code. Length of the code means number of bits. So number of bits here it is 2, 2, 2, 3, 4, 4 and so on. So based on the code word length and probabilities, that is P of x1, P of x2, we can able to calculate the coding efficiency. So here the formula for coding efficiency is h by L into 100. So if you know the information theory concepts, you will have some knowledge about what is h and what is L. Where h is the entropy and L is the average code word length. But here I am not going to explain about these basic things. Just I am here to explain about how to identify the coding efficiency based on that formula from the Huffman coding procedure. Okay. So h and L we have formulas. So summation of I equal to 1 to n p of xi into log of 1 by p of xi, where we know that p of xi. P of xi means p of x1, p of x2 and so on. So you can implement I from 1 to 6. So we need to add based on this multiplication. P of x1 into log of 1 by p of x1. That means p of x1 is 0.3. That means 0.3 into log of 1 by 0.3 plus again 0.25 into log of 1 by 0.25 and so on. If we add the summation, we will get h value, that is entropy. We will call this as entropy. Next, L is average code word length. Again, we have a formula for this, that is summation of p of x into L of x. So that means what is the formula is probability into length. So 0.3 into 2 plus 0.25 into 2 plus 0.2 into 2 plus and so on. Then we'll do that. Then L will be obtained. Okay. So h will be getting with 2.34 bits as an example here, and L will be obtained as 2.38 bits per second or bits. So totally you can substitute h by L into 100. So finally we get some kind of percentage of efficiency as 98.3%. So that indicates that the code is 98.3% efficient. Okay, like that you can easily calculate for any example. For any example, you can easily calculate what is the coding efficiency. Okay, so it is just a calculation part. By using your calc, you can do this in a very easy way. Okay, but this is most important thing: how to implement Huffman coding, how to find the code words. This is very important. So try to practice this with more examples. You can take any number of symbols with probabilities. So try to implement this Huffman coding as per this procedure what I have explained. Okay, and there are more examples you can see, like sometimes the table will be given as set of probabilities. Set of symbols with probabilities are already given in the table, so you can construct the Huffman coding for the following table. And sometimes you will give the probabilities and set of symbols as per the previous example directly like this. And what most interesting thing is, sometimes no symbols are given and no probabilities are given, but we need to construct the Huffman code and find the code word or encoded bit sequence for a given message. Here one message is given, either name or a message or whatever. For that particular message, how to apply Huffman coding. That is very important and useful, because practically how you are communicating, how do you send the message from your WhatsApp or Messenger, you will type a message like, you need to type some letters like D, A, D, I, E, S, something like that, and when you press enter, so that message is going to be transferred in the form of ones and zeros. Finally at the destination it will be recovered into from bits into again text message. So during this process, how these message or group of letters are going to be converted into bits. Okay, how D is converted into ones and zeros, how S is converted into ones and zeros. That is the most important thing. Okay, and you can also try with your name. So write your name on your paper and apply Shannon-Fano coding or Huffman coding. Then finally, for each letter you get the code like this. For each letter you get the code like this. So write this code as per your name order. Okay, then you will get a final encoded bit sequence for your name. So let us also see this example. Okay, this is very useful. For example, convert your name into encoded bit sequence using Huffman coding or Shannon-Fano coding. Here I am considering Huffman coding. So let us consider the name as Sai Krishna. Sai space, his space is also considered Sai space Krishna. Okay. The first step from the message we need to observe is identify the number of distinct symbols. Distinct symbols means if the symbol is repeating, that will not be counted as 2 times or 3 times, only 1 time. For example, how many symbols are there? S, A, I, so space will be represented here like this. K, let us assume no case sensitivity. R, I. So I will not be written again because I is already counted. It is repeating. Next S is already counted. H, N, A is already counted. Okay. So 3, 4 and 4, 8 symbols are there along with space. So we need to write these set of symbols like this. Then identify the probability. Probability is not given in your name. We need to identify based on the occurrence of each symbol in your message. For example, how many spaces are there here? First we need to identify that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total 11 places are there, 11 occurrences. In these 11 places, based on the occurrence of each symbol, you can easily write the probability. For example, S will be repeated 2 times. So the probability will be 2 by 11. So 2 places it occurs out of 11. Next, A will be again repeating 2 times. So 2 by 11. I also will be repeating 2 times, 2 by 11. And I, K and all the remaining symbols occurs only 1 time. So that's why it is 1 by 11, 1 by 11 and so on. So if we can do like this, then it is very easy to implement Huffman coding. So if you observe this table, then the procedure will be same. As we already explained in the previous example, you can easily implement Huffman coding or Shannon-Fano coding according to these symbols and table, or according to the symbols and probabilities. Okay. Now let us see this, how these are implemented. The first step is we need to arrange the symbols in the decreasing order of their probabilities. That means what is the highest probability? 2 by 11. Of course, we have 3 equal values with 2 by 11. So we need to move according to the order of your message. So first is S having the 2 by 11. So that's why write S, A, I, 2 by 11, 2 by 11, 2 by 11, and then next values with the lowest probability. So the Huffman coding procedure will be repeated. So what is the procedure? The first step is assign 0 and 1 to the least 2 probabilities, and then add these 2 probabilities. The total sum of these 2 probabilities will be again rearranged in the decreasing order of their probabilities in the second stage. So like this it will be repeated. So assign 0 and 1 to these 2 probabilities. So if you add these 2, the sum will be 2 by 11. So that 2 by 11 again must be rearranged here. How these rearranged? So the 2 by 11 will be equal to the highest value, but already 3 values are there, but we need to write this just below the third one, and then this value 1 by 11 will be less than this one, so it will be placed at the below this 2 by 11. Again it will be decreased, so this order will be decreased, and this sum will be moved here. Next, again assign 0 and 1 to the least 2 probabilities. So the sum will be moved to here, and the remaining value will be down to here. Again this assign 0 and 1 to the least 2 probabilities. So sum will be 3 by 11. So 3 by 11 will be highest value compared to all the probabilities. So it will directly move to top, and remaining will be moved down. Next, again assign 0 and 1 to the least 2 probabilities. So the sum will be 4 by 11. Again it will be more than this highest value. So it will be moved to top again. So remaining will be moved down. Okay. Next, assign 0 and 1 to the least 2 probabilities. Sum will be 4 by 11. So already 4 by 11 is there. Just write below this, and then remaining will be down. Next, assign 0 and 1 to the least 2 probabilities. So total sum will be 7 by 11. That is highest. So it will move to top. Remaining will move down. So finally assign 0 and 1 to the last 2 probabilities. So since there is no further continuation, because already we achieved that only 2 symbols are attained. Then how to write the code for each symbol? Just by tracking backward sequence, you can easily write the code. How? Let us see. What is the code for yes? Try to follow the arrows. Just try to follow the arrows. For yes, these are the values. So it will move to here. No code is assigned. Again, it is moved to here. So 0, and then it is moved to here 0, and again it is moved to here 0. So 3 zeros. If you write in a reverse order, also 3 zeros. Next, for letter A, that is, it is moved to here and here. So 1, 0, 0, 1, 0, 0. Reverse way 0, 0, 1. Similarly, for letter I, it is moved to here 0. It is moved to here. No code is assigned, and moved to here 1. Okay. So 1, 1, 0, 1, 0. Sorry. Again, let us see. For I, 0, 1. Reverse way 1, 0. Similarly, for randomly I will take R. What is the code for R? It is moved. No code is assigned here, so it is moved to here 1, 0, 1, 0. So reverse way 0, 1, 0. Like that, you can easily write the code for all the symbols in a particular message. Okay. For example, if you want to write what is the code for the name, how to write the code according to the occurrence of these symbols. So we know all the code for all the symbols. For yes, what is the code? 3 zeros. So 3 zeros. Next, A. What is the code for A? 0, 0, 1. 0, 0, 1. Next, I. What is the code for I? 1, 0. 1, 0, and so on. According to the occurrence of each symbol in your name, you can finally get the code for a particular message or a sequence of symbols or any name, any text, or if you have a time, you can write a paragraph also for every for the entire paragraph. You can able to identify what is the final bit sequence. And if you are more interested, if you want to implement this in more real time, then you can go for any coding technique or any programming. So you can use a MATLAB program or a Python program. If you are good at any programming, so you can directly implement this coding technique. So try to give input as any paragraph or any long sentence and try to observe what is the final code word. Okay. So that is all about Huffman coding technique. Hope this is useful to you. So thank you.